The IMCSCH function within Excel allows us to calculate the hyperbolic cosecant of a complex number. The function itself is quite straightforward, so we write IMCSCH and then we supply as the only argument the complex number. In column A, I have some complex numbers. These consist out of a real and an imaginary part. Now do keep in mind that within Excel, complex numbers are considered as text and not as numbers. Now I close the parentheses and I pull this down. The result is the hyperbolic cosecant of that number. Now, how is that actually calculated? Well, one of the definitions of the hyperbolic cosecant is that it is the inverse of the hyperbolic sine. So if we use 1 divided by the hyperbolic sine of this complex number, we should get exactly the same. So let's give that a shot. So how do we calculate the hyperbolic sine function? Well, we use the IMCSCH function. We once again supply the complex number and close the parentheses. Now we need to pick 1 and divide this by this number. Now we cannot do regular division because complex numbers are not considered as numbers but as text. So we need a special function, and the function we're looking for is the imdiff function, which allows us to divide two complex numbers with each other. So the first number is 1, and then the second number is a complex number we get returned by using the hyperbolic sine function on a complex number. I close the parentheses, press enter, and I will be pulling this downwards. And as you can see, we are getting exactly the same results. So you can use either of these methods. Now, one thing you might not be aware of is that the hyperbolic sine function of a complex number is actually equal to minus I times the sine of a complex number multiplied with I. That's quite an interesting property, so let's take a look at it. So what we are going to do first is take minus I and then multiply this with a complex number. Now to do this, we will have to use the IMProduct function because complex numbers are considered as text within Excel and we cannot do regular multiplication. So the first number will be minus I, and we wrap this in between double quotation marks because this is considered as text. Now the second number will be whatever is being returned from the sine of the complex number times I. So we will have to use the IMSIN function, which allows us to take the sine of a complex number. Now the complex number we want to take the sine from is the complex number that was given times I. So we'll also have to wrap this in another IMProduct function. So IMProduct, and then we are multiplying I, which I once again put in between double quotation marks, and then I'm taking the complex number we started with, which in this case was 2 plus 2i. Now I close these parentheses, and so right now we are taking the product of minus I times the sine of the complex number times I. Now all we have to do is to take 1 and divide it with this number, so I will use the imdiff function for this, imdiff, and we are dividing 1 by the number that was being returned by this sine function multiplied times minus I. I press enter, there we get the result. Let's pull this down. And as you can see, once again, we are getting exactly the same result. So that's quite a unique property to see that the hyperbolic sine function is actually equal to minus I times the sine of a complex number multiplied with I. Okay, now the hyperbolic function is actually defined as e to the power z minus e to the power minus z divided by 2. Now we can also use that definition to calculate the hyperbolic cosecant of a complex function. Now, of course, the letter E here stands for Euler's number, which is 2.7, 18, 28, etc. And we are bringing this to the power z, meaning the power of the complex number. So we are taking the exponential function where the argument is the complex number. So when we're working with complex numbers, we also need to use a special Excel function for this, which is the IMEXP function, which will return the exponential of a complex number. So in this case, we supply as the only argument the complex number and close the parentheses. Now we need to subtract from this, so we are going to use a special function that allows us to subtract complex numbers, which is the IMSUB function. So this will return to us the difference between two numbers, where we subtract the second number from the first number. Now the second number will also be an IMEXP function result, as we will be taking the exponential of minus this complex number. So first we need to multiply this complex number with minus 1. This we can do with the IMProduct function. So the first argument is minus 1, which we multiply with the cell in A2, which contains our complex number. So I close three parentheses. So what we have right now is we have e to the power z minus e to the power minus z. Okay, so now we need to divide this by 2. So for this we use the imdiv function, which allows us to perform divisions with complex numbers. So we are taking this entire number and dividing it by 2. And then I wrap this in another imdiv function where we are taking 1 and dividing it by this number. I close the parentheses, press enter, and there we have the result. When I pull this through, you can see we are once again getting exactly the same result because, like I mentioned, e to the power z minus e to the power minus z divided by 2 is a definition of how we calculate the hyperbolic sine function. And so 1 divided by the hyperbolic sine function gives us the hyperbolic cosecant function. So that's our result. So whenever you are looking to calculate the hyperbolic cosecant of a complex number, use the IMCSCH function within Excel. Thanks for subscribing and leaving an optional tip. Consider watching this video next.